Hello and welcome. In this video, we're going to talk about the basic rules for differentiation, how to find the derivative, not this long drawn out limit way that we have been finding the derivative, but how to find the derivative using some shortcuts. So our goal in this lesson is that I can find the derivative using the basic rules. Let's go ahead and jump right in. All right, so here are the basic rules of differentiation, and what we're going to be doing after this is just using all these different rules in a variety of problems so that we can practice and make sure we understand each one. So the first rule is the power rule. The power rule, which easily follows from the way we've been doing the limit definition of derivative, says that if I take the derivative of a polynomial term, something to the power of a number, what we do is we actually just drop that exponent in front and we subtract 1 from the exponent. So the derivative of x to the third would be 3x squared. The 3 drops down in front and we decrease that exponent by 1. That's called the power rule. The constant rule says the derivative of any constant is 0, so the derivative of a number is 0. The scalar rule says if you're multiplying a number by a function, you can just find the derivative and then multiply by that number afterwards. So just like with limits, we can pull the scalar out and then multiply it back in at the end. The sum rule basically says if we're looking at multiple terms in a row, we can find each of their derivatives separately. So if I was taking the derivative of x to the third plus x squared plus x plus 2, I could find the derivative of each individual term. So 3x squared, x squared would become 2x if I use the power rule, x would become 1, and 2 would become 0. So we can take the derivative of each individual term and then add them together. Now for the trig rules, all of these rules you do have to have memorized. For the trig rules, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine. The derivative of tangent of x is secant squared of x, and the derivative of cotangent of x is negative cosecant squared of x. The derivative of secant of x is secant x tangent x, and the derivative of cosecant of x is negative cosecant x cotangent x. And you can actually prove these first two using the limit definition, and then you can prove the rest of them using a combination of that and the product and quotient rules that we're going to learn in future sections. If you want to check those out, you can look at some of my AP Calculus videos, and I do the proofs for a lot of these in those videos. But let's focus the rest of this video on practicing and making sure we know how to use each of these derivative rules. All right, let's look at these two examples first. So for the first term on number 1, x to the fourth, we're going to use that power rule that we learned. So we're going to take the exponent that's already there, 4, and we're going to drop it in front, and then we're going to decrease the exponent by 1. So the derivative of x to the fourth is 4x cubed. The 2 in front of cosine is just a scalar, so I'm going to just rewrite it. And what we learned on the slide before is that the derivative of cosine of x is negative sine of x. And then I'm just going to slightly clean this up. 4x cubed minus 2 times sine of x. Here is my derivative function. So now if I needed to evaluate this derivative when x equals 0 or 5 or pi, all I would have to do is plug it into the function that we found. All right, let's look at number 2. First thing, I can't write f prime of x. I either need to write dy dx or I need to write y prime. So I'm going to write y prime. 3 times, I'm going to drop that exponent down, negative 2/3 times x. If I subtract 1 from 2/3, that's the same thing as subtracting 3/3. So that's going to give me x to the negative 5/3. The derivative of 200 is 0. And the derivative of sine of x is cosine of x. So let's clean this up a little bit. This is going to give me negative 2x to the negative 5/3 plus cosine of x. You do not need to rewrite with positive exponents. Let me put up a couple more problems for you to try on your own, and then we can work through them together. All right, here's 2 more problems I want you to try on your own. I'm going to give you one hint. It would be helpful for both of these functions for you to rewrite using negative exponents. So the same thing on number 4, and then take the derivative. So go ahead and pause the video, work through these 2 on your own, and then unpause the video and see how you did. All right, for this first one, the derivative of 5 is 0. If I drop -3 down, -3 times -1/2 is going to be 3 over 2 times t. Make sure you didn't turn that t into an x. If I take -3 and I subtract 1 from it, I'm going to get -4. Make sure you got -4 and not -2 there. And then the derivative of tangent of t is secant squared of t. And since tangent is negative, the negative is going to follow the secant. All right, number 4. We're going to rewrite using negative exponents and then take the derivative of each term using the power rule, and here is our derivative. So go ahead and pause the video, make sure you have everything correct for these two problems, and then we're going to move on. All right, we're going to learn one last topic, or sort of formalize one last topic, and then just go through a handful more examples before we wrap up this video. The average rate of change is the rate of change you've been finding for a really long time, the slope between 2 points. Slope, just like when we were talking about lines. That's abbreviated AROC. The instantaneous rate of change, or the IROC, is the derivative. So if you're being asked to find the rate of change between two x values, you're being asked about the average rate of change or the slope of the secant line. If you're being asked for the instantaneous rate of change, you're being asked for the derivative. So if we look at this example over here, number 5, and we take the derivative of x squared minus 5, using the power rule, x squared is going to become 2x, and -5 is going to become 0. So there's our derivative as a function. If we plug in 3, which is what B is asking us to do, we're going to get 6. Now part C is giving us two x values, so this is asking us for the average rate of change. So we're going to plug in 3 and 11. So this is going to give us f of 11 minus f of 3 over 11 minus 3. And here's f. So go ahead and pause the video and plug those values in and simplify this fraction. That's going to give us 1/16 minus 4 over 8, which if we simplify is going to give us 14. Let's look at a couple more examples and then wrap up. I'm going to encourage you to pause the video and work through number 6 on your own. I'm going to remind you that the square root of x is the same thing as x to the power of 1/2. So hopefully you had time to work through at least A and B. Part C is saying if we already found the slope, this is our slope, in part B, can we write the equation of the tangent line? So we know that for the equation of the tangent line, we can say y minus 3 equals our slope times x minus 9, and we just found the slope in part B. So we're tying together tangent lines to the idea of the derivative giving us our slope. Let's look at another example. All right, go ahead and work through this example on your own and then unpause the video and see how you did. And here we have the solution to that. -4x to the -3rd is going to be our derivative as a function. If we plug in 2, we're going to get 1/2, and then we can use that information to write the equation of our tangent line. All right, let's throw a little bit of trig in there. You're going to do the same thing, find the derivative, and then plug in pi. Unpause the video to see how you did. All right, so the derivative is going to be cosine of x minus sine of x minus 4. If we plug in pi, cosine of pi is -1, sine of pi is 0, so this is -1 minus 4, which is going to give us -5. We're going to look at one last set of examples, and then we're going to wrap up this video. All right, so now instead of just finding the slope, we're being given some other way that this question could be asked. So number 9 says, determine the x values for which we have a horizontal tangent. What does that mean? That means that our slope is going to be 0 if we have a horizontal line that has a slope of 0. So what we're going to do is we're going to first find the derivative, and then after we find the derivative, we're going to figure out what x values make it equal 0. So go ahead and find the derivative, and then set your derivative equal to 0 and solve for x. Then unpause the video and see how you did. So our derivative is going to be 3x squared minus 6x. If I set that equal to 0 and factor, I'm going to get two solutions that x is either equal to 0 or x is equal to 2. Lastly, number 10 asks us to figure out where the slope is 18. So similarly, we're going to find the derivative, and then we're going to set it equal to 18 and solve for x. So go ahead and work through that, and then unpause the video and see how you did. So we should get 3x squared plus 6 equals 18, which is going to give us that x is positive and -2. Let's go ahead and wrap up this video. In this video, we learned the derivative rules and shortcuts for finding basic derivatives. We extended that to the idea of writing the equation of a tangent line or evaluating that derivative at different values. And lastly, we talked about how can we find that derivative and then figure out when that derivative is equal to something specific. So our goal was that I can find the derivative using the basic rules. Go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.